Good day, students. Welcome to theme 4, Project Quality Control. Alright, so by now you've got an introduction to to quality management in general as applicable to projects. Then we did the quality planning and we've done the quality assurance. And so the next step is now project quality control. So remember that the main difference between quality assurance and quality control is that quality assurance focuses on making sure that you followed the processes, whereas quality control is to make sure that the product meets the specifications. So that's like a very high level summary, but just keep that in your mind when you think about what is assurance and what is control. Alright, so after this theme, you need to be able to define quality control and its benefits, apply the 7 basic quality tools, define statistical sampling, define and discuss inspection, discuss quality control measurements, discuss validated changes, discuss verified deliverables, discuss work performance information, discuss change requests, and discuss process asset updates. So unfortunately, you will see that this is quite a theoretical theme, and you will then unfortunately have to study most of what is in this theme. The good news is that the 7 basic quality control tools, which are sort of the crux of quality control, we've already done, because it's exactly the same tools as what we do in quality planning. Right, so these are just the resources. So just so that you can see where we are, we're here on project quality control, and there's only 2 more themes left. Okay, so quality control is the process of monitoring and recording results of executing the quality activities to assess performance and recommend necessary changes. So you can see it is looking at the products of the project and making sure that the product of the project is meeting the standards. The key benefits include identifying the causes of poor process or product quality, recommending or taking action to eliminate them, validating the project deliverables and work that it meets the requirements specified by the key stakeholders, and it's necessary for final acceptance. So quality control is an internal process according to how we see it from the project management perspective, and it is to make sure that the product that we are delivering to the client is ready for final acceptance. Okay, so here are the inputs, the tools and techniques, and the outputs that we need for quality control. And you will see that there's the project management plan, then the quality metrics. So this is what we've set up during quality planning. For the quality checklists, the work performance data. So this is the data that we've already gathered in terms of how the work is going. Approved change requests, the deliverables, because obviously we need the deliverables to check the quality on those. Project documents, and then organizational process assets. Then the tools and techniques are the 7 basic quality tools, statistical sampling, inspection, and then the approved change requests review. So we look at the approved change requests and we make sure that those have been implemented on the project. Then the outputs are quality control measurements. So we now take our products and we apply the checklists and we measure, and we then make sure that the changes have been done, so that's validated changes. Verified deliverables, so we verify internally that the deliverables are ready for acceptance. Work performance information, change requests, project management plan updates, project document updates, and organizational process asset updates. Right, so here is the data flow diagram. and you can see that quality control or control quality is sitting in the middle, and plan quality is an input to control quality, and control quality is an input to perform quality assurance. Because remember, perform quality assurance is making sure that the correct processes have been followed. So in other words, in quality assurance, we check that quality control has been done correctly. Right, and then you'll see there are other processes that are inputs, and outputs or quality control then feeds into monitor and control project work, perform integrated change control, and then the important thing is validate scope. Validate scope is where we sit with the clients and we get client acceptance. So you can see that according to the PMBOK and according to the project management literature, quality control is an internal process that we do before we ask the client to accept the scope. Right, so here is the good news. There are 7 basic quality tools that you already know. And as you have seen in the test so far, there will be a question and there will be a practical question on the quality planning tools in each test and in each exam. So it's important that you know the definitions of these things and that you know how to apply them. Okay, so statistical sampling, I am just repeating it here, but you will see it's exactly the same slide as from quality planning. This is where we choose a part of the population of interest for inspection. For example, 10 engineering drawings are selected from a random list of 75. So why do we do that? Why don't we just inspect all 75? Well, basically because the 75 would take us too much time and too much cost to do, and so we use a principle that if we take 10 and those 10 are randomly selected and they are fine, then we can assume that the process is good, and so we can assume that the other 75 are good. But of course, if you check the 10 and every one of those 10 has a problem, then you have to go and check all 75, and you need to go and then find out what's the problem with the process. And we determine the sampling frequencies in the quality plan. So remember, these things don't just happen randomly. When we plan for quality on the project, we have to decide what do we want to inspect, what do we want to review, how often do we want to inspect, how often do we want to review. And the sample selected should represent the population of interest. Okay, so inspection is an examination of a work product to determine if it conforms to the documented standard. So the documented standard will come from the scope baseline, which is your scope statement, your work breakdown structure, and your work breakdown structure dictionary. And of course, those are derived from the requirements. So the results of an inspection generally include measurements and may be conducted at any level. So by that we mean we can look at the result of a single activity and we can inspect that, or we can look at the final product. So sometimes we have inspections as we go along to make sure that we are following the right process and to make sure that we get to the end goal where we want to be. And then inspections are also used to validate defect repairs. So if during inspection there's a problem and we have to rework and repair a defect, that defect must also then go through inspection again. So the terminology that we use in inspections is reviews, peer reviews, audits, walkthroughs, and in some application areas these terms have very narrow and specific meanings. So in other words, in software, a walkthrough has the specific meaning of a code walkthrough where you will have more than one software developer sitting and going through the code and checking the quality of the code, making sure that the code is doing what it should be doing, making sure that the code is documented correctly, etc., etc. With reviews, our example previously of the statistical sampling, where we select 10 drawings to review, you can see that that is an inspection. So we use statistical sampling in inspections as well sometimes. All right, so then the output of our project quality control is quality control measurements. So this is the documented results of quality control activities. So it would depend on what we used, but if you think about a checklist, that would be a very good tool to use to capture or to document the results of quality control activities. And remember that it's captured in the format that was specified through the plan quality management process. So during plan quality management, you have to say how you are going to measure quality, and then those measurements are taken and documented. Then at the end, or another output of quality control of validated changes. So this is where we have change requests that have come through on the project, and so if anything has changed on the project, we have to now check and make sure that those change requests have been implemented. And also, if we've done inspections and there is repair necessary, we need to make sure that those are correct. So we inspect them, we either accept or reject, and before notification of the decision is provided. Rejected items may require rework. Okay, so if we have rework, you can see that the process will then start over again, and it will have to, the repaired items will again have to be inspected and either accepted or rejected. And remember that with quality, this is what we're trying to avoid. We are trying to avoid rework, and that is why we have quality assurance, where we ensure that our processes are good so that we don't have to do too much rework. Right, then the verified deliverables. This is again an internal procedure where we make sure that the deliverable meets the stakeholder requirements. And a verified deliverable has been verified by the internal organizational processes. And this is used as an input to validate scope. Remember, we said that validate scope is where we now sit with the client and we get acceptance from the client that the deliverable is meeting their requirements. Work performance information. This is the performance data that we collect from the various controlling processes. This data is then analyzed in context and integrated based on the relationship across the areas. So we have to make sure that the interfaces are correct. We have to make sure that the data flow is correct. So if, for example, in a software project, we've designed a GUI where you are able to input information into a database, we have to ensure that the database is actually accepting that data, and that the GUI is actually generating the data in the correct format. So examples include information about project requirements fulfillment, such as causes for rejection, rework required, and the need for process adjustments. Then change requests. So these can happen at the end of as an output of the control quality process, because we can now recommend, after we've looked at the quality of the product, we can now recommend corrective action or preventive action. So if we have a problem with the quality of the deliverable that's coming out, we can now say, all right, change the process to correct it, or do something to prevent it from happening again. And then unfortunately we have to repair defects. So this requires a change in the project management plan, because remember our original project management plan, for example, said in the checklist measure the diameter of the pipe, and now when we do correct, or when we have done quality control, we see it's not just good enough to measure the diameter of the pipe, we also have to measure the length of the pipe. So that means that our checklist has to be updated, and that this is a change to the project management plan. And a change request should be initiated in accordance with a defined perform integrated change control process. So if you remember in PJPA, we talked about the integrated change control process as part of project scope control. Right, and then we also need to now update our organizational process assets. So our completed checklists become part of the organizational process assets. Okay, so what are organizational process assets? Organizational process assets are those procedures, it's the organizational culture, it's the way in which we work in the organization. So the completed checklists become part of the organizational process assets, so that when we do a similar project in future, we can refer back to those checklists and we can see how did we do it previously. Right, and so from that you can see lessons learned. Documentation is very important as well. Now we have spoken about lessons learned in PJPA, and we've spoken about how to capture lessons learned. But when we talk specifically about quality, the things that we are looking for are the causes of variance, the reasoning behind why we chose a specific corrective action, because obviously there would be more than one way of correcting something, or there would probably be more than one way of correcting something, but we now have to capture why did we choose that way above another way, so that the next project can learn from that. And then also any other types of lessons learned from the control quality process. They are documented so they can become part of the historical database for both the project and the performing organization. And this is where, if we have a project management information system that captures lessons learned, it becomes really helpful, because we can then put those lessons into our PMIS. Okay, and that, dear students, is the end of the control quality theme. So good luck. This is a theoretical theme. You need to understand all the wordings and all the definitions given, and you can expect questions around discussing the definitions of each of the elements that we've discussed in this theme.